Broadcasting from the Any Hour Services podcast studios, I'm your host, Mike Wilson, and you're listening to In the House. In the House is a podcast about the major systems in the house: electrical, plumbing, heating, air conditioning. Each week, I'm joined by a panel of experts. We pick a topic and we discuss it in depth. It's meant to be informative and hopefully bring you some value. On this episode, we're going to be talking about water pressure. What should it be? What happens when it gets too high? And how can we fix it? I've got Ricky, Dwayne, and Scott here with me today. They're the plumbing managers at Any Hour Services. Welcome back, guys.
How's it going, Mike?
Good to be here.
So good. A podcast is being recorded. Why would I not be awesome?
I can't think of a reason.
Good answer. All right. So we'll just kind of dive right into it. I don't actually have a question for you, Ricky, about like when water pressure was invented. I just think when there was water, there was pressure. You actually have an answer? Do you have an answer for like the PRV? Okay.
The first safety valve was invented in 1681 by Dennis Papin, a Frenchman.
Ah. Is that why it's a PRV? It used to be a Papin reduction valve.
No, it didn't.
It didn't?
No.
Oh.
That's all I got.
That's all you got. Okay. So we'll talk about PRVs or pressure. Is it pressure reducing, pressure reduction? What's the R in PRV stand for?
Yeah, it's pressure reduction valve, but we like to say pressure regulating valve.
Regulating. Okay.
Because it regulates your pressure.
It can send it up or down.
Yeah.
Okay.
Yep.
So we'll talk about the PRV much more in depth, but let's actually start with the basics. Dwayne, if you'll field this for me, how does house water pressure actually work? Where does that pressure come from?
All right. Well, that is a good question. So I've been doing this for quite a while, and in my trade, I saw regulators starting to be coming in homes as a required thing about 1985. Prior to that, and I think we still see that in our homes today, we see homes that were built before the 80s that don't have a pressure reducing valve, pressure regulating valve in there and things, and it's a big concern. So water comes from the street.
Water's in the street. So the water,
it just comes
the water that goes into those drains, that actually just comes into the house.
Yes. No,
that doesn't make
come
sense.
on, Mike. We don't drink the drain water.
Well, they say, what is it? The slow the flow, what goes down the drains. Like, how's that slogan? And I don't know. Anyway, so where does it originate?
I don't know. I'm not sure where to go with that last question.
The city water, like where?
Okay,
right.
So
the city has a water plant, and then they're big pumps and things,
correct.
Right? So that's where the water comes from.
So the water's coming out of the ground, out of the mountains, out of lake streams, out of aquifers, depending on where everything is, and the city then takes it and treats it, and then puts it out into the system.
And they have does the pressure come from the big pumps that they're forcing the water down, or is it gravity fed?
It can be multiple different ways depending on where they're getting their water from. It used to be that when the Utah Wasatch Frontier was small, all of our water came out gravity fed from the mountains. But we've gotten larger and larger, and like we all know, Salt Lake Valley has expanded all the way across and going up the other mountain on the other side. And so they've added wells, they'll drill things, pump things up into tanks. You'll see driving around where they've got these big 1,000,000-gallon tanks that they weld all up, those kinds of things.
Because like growing up in Louisiana, most of our towns had a water tank. And it's that iconic look of a big bowl looking thing with Joe Diffie, R.I.P., he passed away. But he had that John Deere Green song about writing on the water tower. And for a long time, I didn't actually understand how the water towers worked. But anyway, so that gravity fed there. But so most of the time here in Utah, most of the time it's going to come from the city with pumps and things forcing that out to
treated and chlorine and all that fun stuff. So, but what we run into, and the reason we need the pressure regulating valves is our infrastructure has not changed. Streets that were built in the 70s and roads and everything, when they build a new subdivision or whatever subdivision you're in, they brought in a certain pipe size, and that's what you have. Then they make a new road through your subdivision into another subdivision, and tie onto that line, and it goes into the next subdivision. And so we find that our infrastructure has been added to, and I think therefore the change in the mid 80s came about when all these subdivisions started growing, because the city had to start cranking up the pressures and putting more pressure in the pipe to make sure that it gets all the way through as the pipes start large and get smaller and smaller and smaller as they continue to add and add and add. So that's where it's become historically a very much more important part of what we do in our plumbing. I think the cities back in the day could just control it and say, we've got 500 homes we're feeding. This is what we'll do.
So as they add another batch of homes, they tap into whatever water feed line there is going to it. That they don't trench another water line from the
tower or
the tower
the
or
source.
the source, the pumping stations. And so the further you get down line, the lower the pressure would become. Therefore, the city has to crank that up, and that would cause the people at the front of the line. Am I correct in assuming that the people on the front of the line have more pressure at that point, like a higher pressure?
Well, do you want to talk about pressure as pressure versus volume?
Yeah, not necessarily they have more pressure. There's two distinctions with water pressure. That we have the water volume, how much water is coming through the pipe, and then we have the pressure that's behind that water.
Okay.
So yeah, it doesn't necessarily mean that they're going to have more pressure because that pipeline is pressurized from start to finish. The pressure is equal, so it's not going to be any more or less on that line. Now, as water becomes less and less from the plant, like if it lowered in the pipe system, your pressure would reduce because the volume's reduced.
Well, that's a good distinction, because I don't know if a lot of people, I think when people think of water pressure, they're probably thinking about the volume of water coming out. And so it's not necessarily a pressure issue as much as a volume of water coming out. Is that accurate?
Yeah, and a lot of that has to do with the sizing of pipes in your home and the fixtures that you're installing. All of that plays into your water flow.
So, but when plumbers come out and when homeowners talk about it, they talk about pressure. And so, and we just talked about a pressure regulator. So, and that's what we measure when we go out to a house is the pressure. So tell me, why is pressure what we measure and not volume of water?
Well, I mean, we actually...
Sorry, I'm just going where you guys are taking me.
Yeah.
This wasn't in the pre-note show. I'm just a curious dude, and y'all bringing it up. Yeah.
Do you guys agree at prime times, like shower times in the morning when everybody's getting ready for work and things like that, when they get home from work, that pressure can fluctuate too at those high volume times too, that a lot of homeowners would never even consider?
Absolutely. I agree with that, because I mean the pumps are designed to keep that pressure and that demand coming through the system. They're not just set at a certain, I mean they those pumps are moving high and low based on demand to keep the pressure consistent. So yeah, if you're using a lot of water, absolutely.
All right. So then let's talk about pressure. What should, and we'll talk about how to test it and all of those things. Oh, I left my pressure tester up. Did you bring one of those? I left mine up. Okay, perfect. I left mine on my desk. So what should the pressure at a home be?
Gotcha. Let's just take a step back. You talked about the big towers and the tall towers.
Yes.
So even just with gravity flow, for approximately, it's like 0.42 something inches or pounds per foot of elevation. It's about a half a pound per foot of elevation gain. So if you have a 100-foot tall tower, at the base of that tower, you would have 50 PSI, 50 pounds per square inch pressure, approximately. So that's when you see those towers out in the Midwest and those iconic towers, that's what that's all about, is getting enough height that you can get enough volume and enough pressure to make the fixtures work. So the fixtures in the home are designed to work at least 20 PSI kind of a thing. Most of the time, I believe the code says we want about 40 PSI coming to a home, and that's what they strive for as a minimum. PSI in the home would be 40. Ideally, we want to see between 50 and 70 is ideally where they go. Now, the fixtures can handle most, if you were to look at rating plates on almost all the plumbing fixtures and faucets and things, they're probably rated up to 150 pounds. We do have softeners and certain other components and filters that will say 100 pounds max, because there's plastic and fittings and things that can blow apart on those. So it's very, very important that we protect our home and all the fixtures inside and keep it regulated to be the same. Because of what Scott was saying, there are times when it's higher and there's times when it's lower depending on demand in the overall city. And we want this pressure regulating valve to be in the system to be able to then control and limit and smooth it out, so to say, of what you're receiving from the city.
And Dwayne mentioned also that it can handle up to 150 psi, and what he's talking about there also is not that that's a safe range to work on. Rather, it's not going to blow up on you, like it's not going to explode and you have water everywhere. It needs to be in the safe working range for longevity also, and protection. So the metals are fine, they can handle that high pressure, but there's other plastics and gaskets and everything, and the higher the pressure and the worse the water, the quicker they wear out. So that's why drips and things like that begin to happen in a home.
Gotcha. Because it's a pressurized system until you open a valve or a faucet or things like that. And so all of that pressure that's there is exerting outward pressure on all of the, pipes, the seals, the anywhere that, water is, it's trying to get out, right? So, okay, so we talked about, so what should the pressure be? We say we would hope for anywhere from 50 to 70 PSI. How do you actually test it?
Okay, so and you asked the question, I didn't get back around to it. The code says in both the Uniform Plumbing Code and the International Plumbing Code that apply throughout all of the nation, between one of those two, says anything over 80 PSI needs to have a regulator on it.
Gotcha.
So, Scott, do you want to go in on, or Ricky, how we test?
You guys go ahead.
Yeah, so this is a pressure gauge. It's just it's a device that just has a bunch of numbers with a needle and a pin on the end of it, and it's designed to thread onto a hose end, for example, like a laundry tap or the bottom of your water heater, an outside hose bib, and all you do is just screw that on and turn the water on, and you'll get a static water pressure, which means this is the pressure of the water as it's full, and it will give you that reading, and you want that reading to be between 50 and 70 psi.
So you can actually pick one of these up. Well, if you're watching the video, we'll show you a picture of it, but you can actually go to a hardware store and ask them for a water pressure gauge, and tell them that you want the one that hooks onto a spigot, whatever. And $10, I went and picked one up at Home Depot. And tell me, when they turn this thing on, now the one that I picked up, it has, and I'm assuming that this is standard, there's the black needle that registers what the pressure is, but then there's an extra needle and a knob in the middle. What's that for? Yeah,
so this is a one you're going to have to look for, and these are probably less common, the one that you and I are talking about.
Oh, really?
So the red dial is when the water pressure's on, it's going to give us a static water pressure. That's going to let us know what it is when everything's full and pressurized. When you turn on a faucet, you're going to get pressure drop and restriction happening within the pipes. That red needle is going to stay put where the static was, and now the water flow is going to be red as a faucet's running.
Gotcha. So that needle is designed, the combination of the two, reading between the lines essentially, is being able to tell you how much pressure you're losing when you open up different faucets. Is there a specific range you're looking for? Yeah. And when you open a faucet, should it eventually come back and regulate, or talk me through, what people are going to be looking at because here's the thing. I'm assuming if someone's listening to this episode, they probably have, unless you're just curious about water pressure, you are probably listening to this because you've got an issue with water pressure. And I've got this theory in my head that people don't really care if they've got too high a water pressure. That's giving them what they want. Everybody wants, more volume of water coming out. And so you really only start looking into it, most people, I would think, when you feel like the pressure is too low, when you're not getting enough water coming out of the shower head, or you're not getting enough out of the faucet, or it seems abnormally like it's a trickle, or it used to be higher. Am I correct in that assumption?
I think you're probably right on that, Mike. I think that's a good assumption, because I've referred to it as, hey, you've got a car wash shower right now, and we actually need to bring that down to the normal flow. And like you said, people, I want more pressure, I want more volume, and there again, the pressure and the volume are two different things. So what they may be experiencing might not be a pressure drop as much as a volume drop due to some restrictions in the line. Lines build up on galvanized lines, debris even in the system, kind of a thing, can block things up. But the way we want to test is we want to take the gauge, and for us and our technicians, we usually go to the water heater.
Okay.
Now that can be, and I don't necessarily recommend it, if you've got a very old water heater with a plastic valve.
Don't test it there.
Don't test it there. They don't want to thread on very good, and you might get your pliers out and try to tighten it up. And I personally have busted one off. Have you busted one off?
I've watched you bust one off. That's cool.
He's like, Scott's like, I don't make that mistake.
You said that 2
cool to
weeks
watch.
ago as well.
They get the little plastic ones get really brittle, and plastic just gets really brittle,
Sure.
and it doesn't take much, and then all of a sudden you've got.
And you're a strong guy. I mean, that probably played into it.
Well, no,
you don't know how to control your own strength.
No, because I know that I'm dealing with something that's because of what I dealt with. Anyway,
I'll just tease
every once in a while, and stuff, and it just does happen. Ricky,
Sure.
Did you want to share your little experience or that you told us this morning?
Way back in school, I broke one off during class, and the teacher goes, "What are you going to do now?" And I just stuck my finger in there, and he goes, "That's not going to last long."
It was warm.
Yeah, it was hot.
So, okay, I've got two questions. Was this plumbing school?
Way back in the day, yes.
Okay, because I'm envisioning like you're like when I was in school, and I was like, why are you messing with a water heater when you're in school?
Yeah.
But plumbing school, that
Yeah,
makes
plumbing
sense.
Yes.
Got it.
Anyway, so
It's like plugging the dam, right? The
Yep.
finger
There you
doesn't
go.
work very long.
So anyway, so just kind of be a little bit careful with that. But normally that's where we want to
So
test.
if that's where you normally go, let's say that someone goes down, they've got a plastic valve, and they're like, this is an old water heater. I don't want to test it there. Where do they test?
All right. Then you would probably, next good thing would be to go to the washing machine
Okay.
and pull one of the hoses off, and you can put that hose thread on the valve that comes out of the wall.
Okay.
Where the hose screws on. And that's a good way to test as well. Make sure you shut the valve off first, put the test gauge on,
Right.
and then open the valve back up.
Okay.
And then barring that, the hose bibs here in Utah, because we have frost-free hose bibs for the most part, they have what's called an anti-siphon device in them, and it only allows the water to go one way. And the reason they do that is and so if you put a gauge on the hose bib, you will get a pressure reading, but when you go into the house to open it up and come back out,
I see.
it won't. It's stuck in between there, and it's designed to that anti-siphon device is designed to hold the pressure back from coming in. Say you had your hose down into your tree ring in your garden, somebody hits a fire hydrant, you're up on a hill, the water starts siphoning back out. Now you could get all your nasty water back in, your whole system could get siphoned back in.
Gotcha.
So that's why they call it an anti-siphon device. And that does affect how you can easily test at a hose bib. You'll jump on tutorials and things and see the videos and stuff, and they always have a hose bib that's just a normal hose bib and things like that.
So hose bib will give you static pressure, but if you're going to go to this extra step, and we'll come back to this question that I asked about, what are you looking for in that difference when you open a valve? But if you're just trying to get the static pressure and find out if you've got over that 80, that recommended, or it's recommended not anything over 80 pounds, you need to have some type of regulator on the system. So if you're trying to find out what the pressure is, you could do it at a hose bib, but you're not going to get that full range of testing out of it.
Chances are no.
Got it.
Chances are no.
Especially if it's frost and the older ones where they're not frost proof, those work, right?
Yes.
I got you. Okay.
That would work.
So are we
all right.
ready to go back to the how
Yes.
do we, what's
All
the
right,
number we're
so,
looking for?
Best case scenario, we've got a nice brass ball valve. We feel comfortable putting it on the bottom of the water heater.
Got it.
We put our gauge on. We open up that valve. We read our pressure. We go to our nearest sink, and we like to test it at a sink faucet.
Why?
Is just because it gives a good minimal flow. Okay. And so we open up the sink faucet, and then we go back in and we look and see what our gauge is reading. And we want to see somewhere between a 5 and 15 pound drop in pressure.
Continuous? Meaning,
Yes.
Meaning like, okay, it goes up and it stops at, 70 pounds. And then when you open a valve, you want to see it somewhere between that 60 and 70.
Correct.
Got it.
5 to 15 pounds with one fixture open
Okay.
is considered normal pressure. Because Scott talked earlier about flow restrictions and pipe sizes and things, it can be, you might get a little more, a little less, and that comes into play a little bit. But for our techs, and what we look at is we looked at that 5 to 15 pounds is normal. If it's going through a water softener, there's going to be a little more friction loss through a water softener, so you might see that 10 to 15 pounds kind of a thing. But that is normal pressure. Then you go shut the valve off and come back and look and see what your needle is saying now. Now, it could have been it started higher, and then when we come back, it went down, and it's consistently down, and then it goes back up, but it might be a lower pressure. Okay? And that's one of our diagnostic tools that we use to determine, well, what's causing that? And we start then to look for thermal expansion on a water heater and things. And so it's important to do probably 2 tests to see where we're at, because we might have relieved excess buildup, excess pressure in the system, and then we know that now this is the normal pressure down here.
Before we go into talking specifically about the PRV, let's that pressure reduction regulator
valve
thing. Before we talk about that, because we're talking a lot about like, hey, we're taking all of these steps to diagnose what the pressure is. Is it doing the right thing? Let's actually, in my notes, I kind of put this towards the end, but let's skip a little bit forward and talk about what are some of the consequences. Now, you said earlier you feel like higher pressure is more common than low pressure when people call you out. Is that right?
Yeah.
Like when you show up to a house, you find houses that have higher pressure more often than you find a house that has low pressure.
Right. Yeah, that's definitely going to be more common because we're all tied to the same system.
Sure.
Typically.
Okay. So why, since everybody wants more water volume coming out or what they think is higher pressure, let's go a little bit more specifically. Why is high water pressure bad for the home?
We use things like high blood pressure to help understand things like that. For the same reason, you don't want extra pressure on your veins and arteries and heart. Same thing with your plumbing system. You don't want extra pressure. It'll cause issues in your fixtures, your piping.
What kind of issues?
You can have leaks start to happen depending on the type of piping that you have in your home. You'll start to see dripping in faucets. That's a very common thing we start to see happening is dripping. Even
water hammer where pipes shake and vibrate.
Because you were saying that the fixtures in the house are rated to operate between what and what. Like the maximum rating is, like 100 to 150, but what's the optimal operation pressure there?
So the operation pressure is that 50 to 70 psi.
Gotcha.
So they can handle more.
Sure. Anything above that, it's like you start to red line, right? So anything above that, like it might be able to handle it for a bit, but then all of a sudden all that extra pressure and that wear and tear, plumbing is mechanics as well, and parts start to fail. And when things start to fail in your plumbing, water starts to escape.
And that's a common thing that we hear out there is customers will say, well, we've never had an issue for the longest time. And that's what's going to happen is because it's subtle. You may not have had a problem for 20, 30 years with high pressure, but it's inevitable. Something could definitely happen.
Gotcha. And then, so there's the damage to the fixtures. I'm assuming anything that like you got your bathroom fixtures, your kitchen fixtures, toilets, all of those things. High pressure can affect those and cause them to leak or continue to run, and eventually either wastewater or end up with damage in the home from those leaks. But Dwayne, you mentioned water hammering in the pipes and noises. Like, dissect that a little bit for me. Explain what you're talking about.
Well, sometimes when we get high pressures and different things, one thing I wanted to talk about is that if you do check your pressure and you have somebody looking at the gauge when you shut off the faucet, if you notice the needle going back and forth for a second and then settling on a thing, that probably means you've either got a totally failed regulator or you don't have a regulator on your home. And so one of the things, because
that's not a sign of the gauge going out.
No,
because the speedometer in my old Jeep does that.
Waves all over the place.
It does.
Okay.
Anyway.
All right. So
I have to
anyways,
count the little white lines to know how fast I'm going, and that gets difficult. You've got superpowers like me. Sorry, I derailed it.
All right.
Dwayne's frustrated.
And
So
well,
go
and we
ahead, get back
derailed
to
so
plumbing.
far that the old man brain forgot the question.
You were talking about actually, and then I did. Oh, okay. You said if someone tests the water and when they open the faucet and the needle is going back and forth, that's a sign that you either don't have a regulator or your regulator is starting to go out.
All right.
That's where you ended.
Gotcha. And then I was going to talk about too that without a regulator, one of the things it does, it protects us from the city system, both with the high pressures and slamming. And I mean, it's an outside system. Things can happen. They can open up a valve too quickly and it can cause a rush of water and air if they've done a repair somewhere, and it can slam into your house. And there are instances where, all of a sudden the top of your toilet valve blew off because of that slam of water kind of a thing. And so there are instances that happens. And so that pressure regulating valve helps avoid that happening to your home. I mean, it's a safety device that really does protect your home.
Gotcha. So, okay, go back to water hammering. I don't quite understand. Like, I want to make sure, is the sign, if people are experiencing water hammer, is it just that they're noticing noises? Do the noises only occur when they open a faucet? Like, how does someone know that they're having this problem you're about to describe?
All right. Well, and it's not 100%. It's not, water hammer can be caused by a lot of things.
Okay.
But higher pressure sometimes adds to it as you have higher pressure, and like you said earlier, higher pressure and volume now coming through, say, your kitchen faucet or your toilet. The toilet is one of the notorious ones. So the toilet's filling. It's filling a lot faster, as that tank is filling up a lot faster than it should have been because of the volume. And all of a sudden it reaches that point and it goes chunk and it shuts off. Well, that chunk, as it shuts off, sends a vibration. It bounces the water waves back through the piping, and then it can start hammering somewhere where there's a loose pipe, somewhere where it wasn't strapped properly, somewhere where maybe it's touching a piece of the ductwork, and it causes a loud banging noise that echoes through the whole house because the ductwork is acting as a magnifier and doing that. So it's a real common system where you have the higher pressures and the flows. Our dishwashers are another one where it's a solenoid valve, and it turns on and shuts off really quick and can send a vibration through. The washing machines are another one where we have solenoid valves. Usually at our faucets, we gently...
Silly noise valves.
What's that?
You said it's got a solenoid valve,
Solenoid.
but we're talking about water hammering.
Yes,
and I'm
the
like,
noise.
silly noise
Okay.
valve. And
Solenoid valve.
my humor is old.
Yeah.
It's
not
like
old enough.
Solenoid valve.
squirrel. Okay, sorry. Silly noise. Okay,
Anyway, so
done.
those abrupt stops of water flow, and it can be accentuated with high water pressure. So somebody's been in the house for a long time and they've never had that issue. If the regulator fails, then they could be having those higher pressures, and they're going to start hearing. So they could start hearing some of those noises.
Gotcha. Okay. So let's see. Talk about that. Okay, so now let's talk about what we can do to regulate that. And we've been talking and alluding to this PRV, this pressure regulating valve. Talk to me about what it is, and I'm always curious, how does the thing work?
All right. So usually your pressure regulating valve is in your home. It's usually where the water service comes into the home, and there's a main shutoff valve to the house, and usually right above that, within a foot or two, is the pressure regulating valve. And so you've got a main shutoff valve down below, and then the pressure regulating valve goes above. There is an arrow flow. Let's make sure I'm holding it in the right direction, and then it allows the flow to go through.
So when this is installed, it's designed for the water to flow a certain direction through this this valve, this
Yes.
regulator.
Yes.
Okay.
Yep. It's got a one-way thing on there. So there's a spring mechanism that you can adjust the pressures up and down. They come preset at the factory for the most part to be about 45 to 50 psi. Is the factory setting. Now, if you have 130 psi coming in from outside, it's going to register a little more, a little higher, and you may not need to make any adjustments. And if it's coming in at 90 psi, you might need to make some adjustments on that. And we do we want to just talk about how to?
Let's talk about
Okay.
how. Well, actually, tell me how it works first. You said there's like a spring thing. And we'll put a picture on because you have one that's actually cut open so you can see it. So the water comes into the bottom, or the way you're holding it.
Yep.
Or I guess the top or the bottom,
Yep.
right?
The water comes in the bottom. They're usually sitting in a wall like this. So the water comes in the bottom, and there's a shaft that moves up and down. There's a spring that sets, and then there's a rubber diaphragm in here that moves up and down as well. And that allows this plunger here to, during low flows, it's gonna allow less water in while still maintaining the pressure and not letting it go over the 70 pounds or whatever. And then if you need more flow, you've got a shower running, you've got your tub filling and things, then it modulates down and allows more flow to come through and come out the other side.
And I'm just, as you're explaining this in my head, because I've always like tried to figure out how do I explain this. Like if you've ever been to the ocean and just stood there with your feet in the water, no big deal. But then when the waves start coming in, they can knock you back. They can knock you over, right? Because that water, it has mass, it has velocity, it has pressure, and so this mechanism, it's designed to not equilibrate. Like what's the like?
No, that's actually
is like it's trying to term. Yeah. So you've got the pressure of the water on one side and an equal pressure on the other side that it's trying to regulate. And so when there's more pressure from the water, like whether there's more coming in, like the waves coming in, then this device will tamp that down and it will apply more pressure over here so that you get an even pressure coming out from the water. And then when you're just standing there and there's not a whole lot of pressure, pushing you over, that allows that to open up because you've got, does that make sense?
Yeah.
I like it.
Yeah.
I don't know.
Yeah.
That's because you like the ocean. I did that for you, Ricky.
It equalizes.
Have you been attacked by a shark?
I've been within 500 yards of 4 shark attacks in 50 years.
Like you were 400 yards of 4 shark attacks happening at the same time? Like
No.
they attacked in a pack?
Throughout 50 years, I've been around 4 shark attacks.
4 shark attacks. What, like attacked a person or just like
Attacked a person.
like bit them?
Yeah.
Like blood in the water?
Yes.
Did you go and help?
Twice.
Wow. Were you like freaking out a little bit?
Yeah, it's
Like, did you
I
see the
think
fin?
it's an adrenaline thing.
Like, how did you, like, were you just like out there surfing, doing your thing, waiting to catch a wave, and then you look over and Tommy disappears, or you see a fin, or like, how do you know that it's happening?
They were bit on the legs twice, 2 of the times, and they were off their board, and I paddled over to help, and the other 2, I was too far away, and other people helped.
So, I mean, did this episode took an odd turn, but now I'm curious. It has to do with water and the pressure that sharks put on your legs.
Yeah.
Water pressure. So when the shark attacked, did it like just bite and let go, or did it like
On the East Coast, the sharks, how are we talking about this on a plumbing podcast? I don't know.
water?
When they bite.
Wait, they have a fitting. Sorry, they have a plumbing fitting that they like has the shark teeth on it, right?
Yeah.
So we're totally in line. This is not off topic at all.
So on the East Coast, the sharks they're not really great whites, the big ones like on the West Coast that you can die from. And there has been deaths. When they bite, they realize that it's not what they want and they let go. But our reaction always when a shark attack happens is to rip our limbs out of their mouth because it's reflex. That's where all the damage occurs. And it's usually tendons and stitches and things like that, but no deaths on the East Coast, very rarely.
So that's where your shark attacks were East Coast. Mm-hmm. Where were you surfing?
In Florida.
In Florida.
So let them gnaw on your leg if you're ever in the ocean.
That's what I hear. It's like instead of jerking back, you want to hug the shark.
Let them go, and then they'll realize it's not what they want.
Like,
move on.
Unless that's
not going to happen. You're going to react.
So wow, we're so four shark attacks. Wow, that's nuts. Did you ever like think like, wow, that could have been me? Like, do you ever get apprehensive going back in the water?
Well, when Jaws came out, none of us got in the water for about a month after that movie
Really?
came out. Yeah.
Wow.
Yeah.
I'm still not getting in the water. I only take showers now because of Jaws. I would go to boys camp and they would tell me about beaver sharks, which are freshwater sharks. You've never seen a beaver shark?
Are you baiting me for something?
No, like they exist.
Okay.
Actually, they don't. But as a Boy Scout, I wouldn't go swimming in the lake.
I got you.
Anyway, so back to PRVs.
Pressure regulating valves.
Yes. Now I'm distracted too. Okay, so we go back. How did we even get to that? Why did you bring up shark attacks?
You were giving a great illustration of the ocean.
It's true.
And
then Ricky's like, hey, I've been attacked by sharks.
I think I heard that. Ricky's like, let's talk about sharks for a minute.
I never even brought the ocean up.
You kind of did. You were like, I love this ocean analogy.
No.
Mike, could we talk about sharks?
It equalizes. That's what I said.
You
brought up ocean, and then you brought up surfing. And
I heard, you know what else equalizes? Sharks. They have a lot of pressure in their bites.
So we were talking about how a pressure regulator works and the device that's here. There is also a very important thing.
Yes.
I'm just going to bring it back.
Yeah, to bring us back.
You just lost it over there.
No, I'm good. Go, keep going.
All right. So there is a screen in here that does keep larger pieces of debris from making it into your home. Sometimes they're, like I say, repairs and things like that. They can get mud and dirt and silt into a line and it flushes through and then gets stuck in here. And so there is a screen in here that protects the rest of the home.
Is that a maintenance thing that, like, if you go out there, is that something? Because like yours is sliced in half. Let me see the top where the adjustment thing is. See yours, turn it towards. See yours doesn't have like screws on the top to be able to pull the top off.
Right. This brand does not.
Gotcha. So is that a normal maintenance thing? Should you be able to get to that, or if the valve goes out, you just got to replace the valve?
No, you can get to it by removing this bonnet.
Oh, gotcha.
This bonnet up here, you can get to it and remove it, and then that opens things up. And this one shows a little bit better how the bonnet, you can unscrew it. They're on pretty darn tight.
Oh, I gotcha.
I mean, they are put on at the factory with pretty hard.
So if you've got low water pressure, you could have, and is that what you were saying? Is that if you've got some low water pressure, you could have something clogging that filter?
Yeah, there could be. It doesn't happen very often. I mean, that's one of the things that we do look for when we're really trying to troubleshoot and diagnose a low water volume situation, not pressure, but volume. When we're looking at that is one of the things that we look at. We might even just go out to the street and look at where the meter is and make sure that the meter valve is full wide open. Because you can still get 110 PSI if a valve is almost all the way closed, but you don't get the volume behind it. So you can test your gauge and it's like, oh, I've got 80 PSI, but the volume can be restricted to where it drops way down. And so when you asked about the normal drop we like to see is 5 to 15 pounds of pressure. If it drops more than that with just one faucet open, then we're suspecting that the regulator itself, as you look here in the screen, there's parts that move. It's got rubber in here. It's got other devices that can calcify and stop moving and doing what they do. And that's where we do the diagnosis with the gauge, is to make sure that this valve is moving, it's dilating, it's being able to move. We often replace windshield wipers, and you go and you get your old windshield wiper that's leaving 5 streaks, and you pull it off, and big chunks start to break off of that windshield wiper because it's very hard and brittle. The brand new one that you put on, boy, it just floats to the contours of the windshield, and it looks really good and wipes things off and does its things. Because rubber is a product that does go bad, our tires, everything gets hard and brittle. That same thing can happen with a pressure regulating valve. We ask about how long. People always ask, how long do they last? In our hard water environments here in Utah, around 10 years is probably the average lifespan of one before the calcium buildup, it just stops doing its thing.
Gotcha. So let's assume that someone has one that's working properly, and they go and they test their, how do you adjust it, I guess is where I'm going. Like, how do you adjust a PRV?
You got the fixture over there. Go ahead, Scott.
That's Dwayne. I'll give you that. And then Ricky, you can tell us.
So this is this from your house, Mike? This is a relic. This has been around a long time.
No, actually, a plumber pulled that off of a job, and I thought it looked cool. And I'm always trying to collect pieces, but I know you're trying to say that my house is old and needs you to come and visit. I get it. I got an old house.
Yes. So on these
Appreciate
PRVs,
pointing that out.
most of the adjustments
fun of it.
are. Yeah, I do. Most of the adjustments are on the top of these PRVs.
Okay.
And it's kind of the opposite. When you tighten this thing down, you actually get more pressure as you tighten it down and put more pressure on. And when you open it up, you get less pressure. And once you get a reading on your gauge, you can go in and just loosen this nut and undo this little stem right here, and then tighten your nut back down.
Well, you said loosen will give you more pressure.
As you crank this down in.
Righty tighty.
Yes.
As you're tightening it,
Yes.
it gives you.
You will get more pressure when you tighten it down.
Got
yes.
it. And then when you loosen, you get less
pressure.
Okay, so it's if you think about it, like tighten it down more, loosen it less.
Correct.
And just to clarify, depending on how the thing is installed, if that there is what Dwayne called the bonnet, there is a part that protrudes, like you've got the line coming in and the line going out, the pipe. And then there's a part that protrudes that has either a hex head nut or like this old one right here has a flat head screw that you adjust, crank it in to crank up the pressure, unscrew it lefty-loosey to lower the pressure. But you probably are going to need this valve, this test valve. So let's walk them through the steps. Step 1, put the valve on in the manner that we discussed earlier. Establish what the baseline pressure is.
Correct.
If it's a little high, or I guess a little low if you want, then you can go, first step for a homeowner might be to go to the regulator valve, the PRV.
Correct.
And then start adjusting with the screw, right?
Correct. In and out. And then once you find your setting on your gauge that you're happy with, and you want to go throughout the house and open up several fixtures throughout and make sure things equalize. And then you go back and you double check it again. And then that's pretty much your adjustment on a PRV.
Now, if you go and you do those things and you attempt them and you cannot achieve the pressure that you're wanting, then at that point, do they think about calling a plumber to replace? Are there further tests that you do to this valve to see if it's wrong, or is that pretty much the same test that a plumber would do and a homeowner could know pretty confidently that, like, okay, I've done this type of thing? Obviously, a plumber would verify and do their own tests, but
Scott, do you want to talk about what happens when it's overpressure?
Yeah,
When our gauge pops way up.
Oh yeah,
That tells us?
if you're testing that and you're getting above that 80 psi, you're just getting full city pressure. And if you even try to adjust that pin in or out, nothing's going to happen. Nothing's going to change.
like if that bladder, that little rubber gasket isn't working,
It's not working at all. Yeah, and so you're getting full street pressure. at that point.
The range on these are rated for 25 to 75 psi. So
Got it.
They're
So
adjustable. In that range.
anything over 80 pounds, you know that the regulator's not working.
It
It's
froze
gone.
up. It's done. It's just allowing the full pressure to come in, and so that's
a good tip.
and that's the importance of it. And you keep talking about more pressure. I was reading the instruction sheet this morning in preparation for this, and I don't think we read enough instruction sheets to follow, but one thing I found out today that I didn't know after even 40 years is it says right in here, do not turn this thing all the way down and bottom it out, because it will cause it to fail. It could cause it to fail and not work right by making it go in a backwards position and overextend it or whatever and not work right. And we go in all the time and people want more volume. They're again in volume and pressure. I want more pressure, so they crank it all the way down.
Oh, okay.
And now they could have went beyond what it's even designed to do. And I didn't know that. Did you know that?
Oh yeah, I totally knew that.
You knew that one? Dang it, Scott.
I knew that one.
You did?
Yeah.
You read the instructions.
And
once
this is
before.
the guy that's never left a plug in a garbage disposal.
Right.
Right.
You're so perfect.
Yeah.
Jeez,
We'll
where's
get
the
him.
halo? Can we insert a little halo?
We'll
above
get
his-
him sooner or
Maybe
later.
post-production.
Sooner or later.
So that's actually a good point. Though the little weekend warrior that thinks they know how to correct that, they may go down and cause more damage to that PRV than they realize. So they might be cranking it down, and they're like, "Oh, I'm not cranking it far enough." And when you bottom that out, it can cause that to fail. That
Well,
makes
and
sense.
then the other thing to realize is that in the life expectancy of this, it's at various stages of decay or wearing out or solidifying. We tell our techs if it's more than a year old, we don't want to touch it.
Really? Why?
Because if we try to make an adjustment, it could be that it was already stuck in a position, and then it might overextend and ruin it, and then it can't come back, and then it's a replace kind of a thing. And so it is one of those things where
I'm gonna push you on that just a little bit, because like when a customer like calls you out and you're like, okay, it's over a year old, and you're telling them not to try and adjust it because that could end up in a replacement. But if it's not working, you're saying that the answer is a replacement. Why wouldn't you try?
Well,
You don't want to put a customer in checkmate. You know what I mean? If all this, if it did fail, and or if it hadn't failed, and you end up moving it or breaking it, and then you put the customer to where now they don't have an option. Anything that has water running through it, whether it be your water heater, valves like this, and there's not really a recommendation of how to maintain them. But if something is sitting in water, what happens to it if it's metal? It's going to rust. And so if it's never been moved or adjusted for even a year amount of time, you can see on this particular PRV in our cutout, it's completely rusted on the spring. And we don't know how long that one was in, but we don't know what's on the inside. So I guess we could come in, do a maintenance, tear it all apart, lube it up, put it all back together. But getting it to go back in, they're probably going to be in checkmate and have to replace that regulator.
What can happen on these over a period of time, and if this happened to you, Scott or Dwayne, is when you go to adjust one that's been in for a little while to help a customer out without a replacement to try to get a different variance in their water pressure, you can unloosen this nut, and then all of a sudden you put your wrench or your screwdriver on here, and when you go to put some pressure on it, it turns like a half a turn. Because it just, what it did was it was stuck in a place, and then it just rotated. And then now you have compromised their unit, and it would have to be replaced then. So I've had that happen to me. You, Scott?
Yeah, that's actually happened.
And I like to refer to the pressure is, they never call us out for pressure. They call us out because my shower's not working quite right. My faucet's low. I can barely get any water out of it. And so we got called out to fix a certain thing, and then we find out that the regulator's bad or has issues, or we don't want to touch it to try to increase it. But our tests are usually pretty good. I mean, people don't like to believe our gauges, but the gauge is a very accurate blood pressure test of the home. I mean,
Gotcha.
it's very consistent, and that's why we say what we do. And so,
Do they ever, what kind of warranty do they come with from the factory? Because if you're having to replace it like after, a year and a half goes by and you're recommending to replace the thing because like all signs point to replacing it, like, are they under warranty or do the manufacturers?
right here, warranty on this particular valve are guaranteed against defects of material or workmanship when used for the services recommended. If in any recommended service a defect develops due to material or workmanship, the device is returned, freight prepaid to Zurn Wilkins within 12 months from the date of purchase. It will be repaired or replaced free of charge. Zurn Wilkins' liability shall be limited to our agreement to repair or replace the valve only. So 1 year, as a company, when we install one, we guarantee it for a year as well, parts and labor. And if it fails within that time, but the manufacturer only guarantees the valve, not the labor.
Is there a date on this thing of like when it was manufactured? Are they saying like from a year from it manufactured or a year of installation?
I would say typically
manufactured date.
So where do you find that manufactured date? Is it on the box or?
So on this box here, June, there is a stamp on this particular box.
Got it.
Of June 06, 2019.
Gotcha.
So
it's not an expiration date. The expiration date is a year from that.
We do. Here at our company, all the technicians do write our installation date on our parts and components when we install them.
Got it. Well, okay, so we've talked about a lot of stuff. I mean, let's say that a homeowner sees that thing and they determine, they've listened to this episode and now they're a plumber. And they're like, oh, that's my PRV. On a scale of 1 to 10, how would you rate this as a DIY project?
I think it all depends on your comfortability with.
For you, it's a 1, like
yes,
super easy.
Easy, piece of cake. It really depends on how comfortable you are with water. Water's
so if you can't
really
swim,
worries.
Do not do this.
If you cannot
I
surf,
don't swim well. If you can't surf.
But if you're not comfortable with soldering or things like that, then
so
you
let's talk
probably
about
don't want to touch
let's
it.
talk about what's involved so that we can like give someone an idea. So you got
Did you just say you couldn't swim?
not well.
That's why you haven't been around any shark attacks.
Look, hey, there is a strong case to be made that I'm never going to get attacked by a shark unless shark tornadoes actually end up happening. And if I get drawn up in a shark tornado and a shark does as well, there is a chance.
Just hold still. Let it bite your leg and it'll move on.
Don't react.
At that point, I feel like I don't know that. Well, there's two things. I mean, since you went there,
here we
and
go
just for the record,
Oh,
just
my
for the
goodness.
record, Ricky went there. Ricky brought up shark tornadoes. If you were in a shark tornado, I would think that the shark would be under duress. I don't know that he would be thinking about hunger at that point. But he also may be looking for anything to grasp onto. At that point, when you're just trapped up in a tornado, you're looking for any semblance of like reality or something that's familiar. So you see a human and you're like, I'm going to bite down and hold on to that.
So that's a DIY is what you were saying on the PRV?
Well, I think it's DIY, but do it yourself. But I think that we should stick with tornadoes for a second. I'm just kidding. Okay, so I tried to go DIY, Ricky, but then you were like, Mike, I think we need to talk about tornadoes or sharks. You went sharks. Actually, you started out making fun of me for swimming, not swimming very well. Yeah. So let's talk about doing this yourself. Just walk through the process because you brought up, soldering and brazing and doing things like that. So just realistically, what are the steps of replacing one of these?
And a lot's going to depend on what brand you're putting in.
Sure.
They all have different types of connections, what type of piping's in your home.
And when I'm talking about explain the process, I'm not saying that this is meant to be a tutorial. It's more meant to say like, hey, here's how involved this is to give someone an idea of like, okay, if you're going to try and attempt this yourself, now go find more detailed information, but not necessarily to scare them away. But if you bring up soldering and doing joints that way, I would automatically hear that like, okay, cool. That's probably a project that I'm not going to try myself because I don't have as much experience doing that.
And not to scare anybody away from it, but you are soldering typically, and you're soldering in a very confined space, in typically a finished room where you have sheetrock, carpet, insulation, and so if you feel comfortable having a flame in the wall, then in
a hole that's 12 by 12.
Yeah, very, very, very confined space. We have to cut it out. We have to make sure that the water supply is turned off. A lot of times the valves are old and even those don't turn off. So it is very involved. You have to cut it out. You have to solder it. Again, if you're not comfortable at all with that, definitely call a plumber.
It's definitely not a basic DIY project.
No.
Where the valve is, the valve shuts off the whole home, but your whole home, once you start cracking the nuts to try to change it out, your whole home drains down through that spot. And like Scott said, usually you've got carpet, finished drywall, and everything. So you have to be prepared for several gallons of water that will be draining down and coming out at that, out at that spot.
That's a good point. Good point. All right. Well, anything else you guys want to talk about? PRVs? Sharks? No.
Well, there was a question about can they be repaired?
Yes.
Okay. So, yes, they can be, but I took a poll yesterday of our about 400 years of experience in our plumbing department. I put it out and said, has anybody had any success changing out or rebuilding? They do make a rebuild kit, changing out and rebuilding the valves. And it was 100% no. I've done 6 or 7 of them in my career, and I stopped because none of them were successful. So at that point, it's like, I'm not even going to try. Next door neighbor, I don't even ask me to come in and try to repair it. We're going to replace it because of my experience.
Well, and looking at the way that this thing is built, I would assume that this is one of those where the cost to produce them, like I would assume that you would be money ahead putting, and lifespan of the system, putting a new one in rather than trying to rebuild it. You're not going, it might cost you more to try and rebuild the thing than to put a new one in.
Oftentimes the repair kits are about the same as what a new valve.
Well, there you go. And then
runs.
You got the labor on top of it. And once you repair it, it's not new.
It's not new.
So anything else? No? Okay. That's it for this show. Thanks so much for listening. I hope you learned something about sharks and water pressure and the pressure that sharks put on surfers. Anyway, this has been an interesting episode of In the House. We'll be back next Tuesday. I don't know that we'll talk about sharks, but I hope that it'll be interesting to you. I hope you've enjoyed this episode. If you have, please subscribe. If you do me a favor and go to iTunes or wherever you can leave a review about the show, we'd really like to hear the feedback of what you're thinking. I'd like to thank my guests, Ricky, Dwayne, Scott, for being here. Austin in the background, Cam's back there co-producing, making sure that things happen, and everyone else behind the scenes that make the show possible. If you'd like to know more about Any Hour Services, go to anyhourservices.com. I've been your host, Mike Wilson, and you've been listening to In the House. See ya.
Thank you, Mike.
You're welcome.